Welcome back to Power BI Bootcamp. I'm Chelsea Doman, and I am very excited to discuss some of the more advanced features of Power BI with you. Through this course, we will introduce you to Power BI as a program. That's what we'll be spending most of our time doing. But we will also discuss Power BI as it relates to features in Excel and the online service called Power BI Online. This has been designed as a hands-on style course with plenty of moments to pause and try on your own. In order to follow along, you will want to download the work files. For this particular section of the course, you'll want to go into your student work files and start with Day 3 work files. In Day 3 work files, you will see an item called Data Model. That's a Power BI file. That's where you'll want to start if you haven't been following along with the course up until now. You will also need to download the Power BI desktop program and a recent version of Excel. Excel 2016, of course, would be nice, but you can also use 2013 and 2010 so long as you are allowed by your company to use the add-ins necessary. If you have Office Online or your company has provided you with an Office Online account, you can also follow the course sections discussing Power BI Online. If you've been following along with the course so far, then this sheet looks pretty familiar with you. In case this is the first video that you're watching in the Power BI series, you'll want to know that we have already been querying information from many different locations. On the right-hand side, you'll see all the different tables that we've been querying. Some of these came in from Excel, some of them came in from online, and some of them came in from an Access database. But there's so many other places that we can query information from using Power BI. On the Home tab of your ribbon in Power BI, you'll want to find the command called Get Data. This is where you issue all of your queries from scratch. Now, a lot of these sources will seem familiar to us already, such as Excel, a SQL Server, analysis services, text and CSV files. We can also, of course, query information from the web, which we have done in Day 1, and from a couple of different locations as well, including a blank query. However, this is not everything that we have available to us. If we click on More, you'll notice that there are so many other really interesting places where we can import data from, like JSON. Here's Azure. We can query information from SharePoint Online list or a SharePoint list. We can query information from Hadoop, from Facebook, from Salesforce. There's your ODBC, Google Analytics, GitHub, MailChimp, and Marketo. Some very interesting locations. So we're going to start off by querying a SharePoint Online list. I'm going to select SharePoint Online List and click Connect. Now, I will need to provide the URL here. So what most people do is they actually go to their SharePoint list location first, and then they copy the URL on that page, and then they just paste it right in here. But in the case that you actually have the URL off the top of your head, like I do, you can go ahead and type it in. And you can follow me along here. Okay, so we're going to https://learnitanywhere.sharepoint.com/Power BI. And I'm taking care here to make sure that I'm spelling everything perfectly. Now's a good time to pause the video and make sure that you get this entire URL. After I click on OK, I will now have the opportunity to put in the credentials for this. So depending on the source, I might actually have credentials for this, or I might want to access this as simply an anonymous user. For our purposes, we're just going to use the anonymous access and go ahead and click on Connect. In this case, I'm just going to need to go ahead and sign in here. So I'm going to click on Sign In, and that's going to allow me to sign into this account and grab that information from SharePoint. And I'll go ahead and click on Connect. I'll see the table right here called Contoso Sales Customers. That's exactly what I'm looking for. I'm going to click on it and click on Load. All right, once that is successful, you should now have your Contoso Sales Customers table loaded in here. If you decide not to do this exercise, no worries, because we're not actually going to be using this data. If you haven't done so already and you want to, feel free to take a moment, pause the video, go to Get Data, and get data from a SharePoint list. You could even try one of your organization's SharePoint lists. For the next big important example, we're going to talk about unpivoting data, which until recently wasn't really a term. But it has now been coined a term, and there is a command that does it for you. Let's first discuss why you might need to do this. You'll see that the data that's presented here on this slide, clearly the top image here is actually of a pivot table, but the bottom example is just an example where somebody chose to populate something as though it were being displayed in a pivot table. The only problem with this is that your pivot table reports are not good data for querying for a couple of reasons. Namely, the data is not structured and columned out by category. We'll see here that we have multiple different periods of time. If we have multiple different periods of time, those things should really all be listed as labels in a single column. So you would have a column that said year, and then a column that said quarter, and a column that said month if you wanted that as well. Instead, what we have here is 2007 quarter 1 and 2007 quarter 2, or something like that. Now, this is really not good data, so what we're going to want to do is take this pivoted result and unpivot the data to make the data much more easy to analyze, model, and utilize in our analysis. We're going to start by getting some data that is already pivoted. So we're going to want to go up to Get Data, and this data is housed in one of the Excel files that's in your work files. I'm going to click on Excel, and we're looking for a file in Student Files in Day 3 Work Files, and we're looking for the file called Competitor Report. Now, if I click on Open, I'll have the option to choose from 3 different tables that are actually pivoted results. So one of them analyzes profits, another one analyzes returns, another one analyzes sales. We're going to start with just taking a look at the profit totals page here. And once we do this, we're gonna open this up, we're gonna unpivot it, and then we are gonna take all of the features that we've applied to this very first one, and instead of reissuing this for the other two, we're also gonna learn how to use another, and instead of doing this individually for the other 2 tables, we're simply going to copy the M script that was applied when we applied our query steps to the first one, and then we'll just paste it in the other 2 tables. So I'm just going to take a quick look, and it does look like each one of these tables look similar. They're all set up the same way, so I should be able to do this just fine. So start by just selecting the table called Profit Totals, and instead of just immediately loading it, I'm actually going to edit some of the query steps here. This is going to launch my query editor, and that's perfect. That's exactly what I want. So this is actually some information from our competitors. So we have data about our competitors and the different product categories that they sell, and the different profit, for instance, listed for those particular categories. So I'm going to want to do a couple things before I actually unpivot anything. First of all, you'll notice that our headers here say column 1, column 2, column 3, column 4. That's not what we want. We'll have to fix that. But before we do that, we actually have this very first row of quote-unquote data that is not actually data, right? This is just a title. So this is a sum of profit report, and then it's listing some column labels here, and then everything else is null. So the first thing that we're going to want to do is remove this unnecessary row here. So I'm going to go find my command called Remove Rows, and I'm going to select Remove Top Rows. And it's just the top 1 row that I want to remove. So I'll type in 1, and I'll click OK. Now's a good time to pause the video and do this and come on back, and we'll keep going. The other thing I don't need is grand totals. If I scan all the way to the right-hand side, I do have a grand total over here. I'm not going to need that, so I'm just going to go ahead and remove this right now. So I'm going to select that column and choose Remove Columns. Then, as we were observing earlier, we do have these column names that are not the correct names, right? Those are just placeholders. So I'm also going to use this command that says Use First Row as headers. Okay, I'm going to scroll back to the beginning here so we can take a look at this data. Our row labels are actually appropriate. These are our categories, or our product categories. So that's okay information to be columned out. Everything else here is inappropriately columned out. There's way too finite sections of detail in each one of these columns. all of this data in these columns need to be combined essentially into one column, or eventually we'll have year, quarter, and month as separate columns. So the first thing that we're going to want to do is select the necessary data to unpivot. A good way to think about this is if you have your labels already showing up in a column, you don't actually need to unpivot those. What we do need to unpivot here is all of the items that are being sectioned out into different columns that should really belong in one time or date column. So I'm going to start by selecting the very first year, quarter, month column here. I'm going to hold down my Shift key and go all the way to the end of my data. I'm holding down my Shift key and selecting the last one, thereby selecting all of the columns except the first one. And this is very important. I have not grabbed this very first column here because it doesn't need to be unpivoted. Now that I've selected all the rest of those columns there, I'm going to go to the Transform tab of the ribbon, and I'm going to find the feature here called Unpivot Columns. After unpivoting your columns, your data should look like mine. If it doesn't, you might want to go back a step just by clicking on this little X right here. Go back a step and make sure that you selected all of the columns that had year, quarter, and month as a header, but not the category labels. We didn't want to select those. All right, so this is looking pretty good so far. I might want to rename some of my columns. I am going to need to split my attribute column too. I would like this to be split by year and by quarter and by month. So I'm going to go ahead and start with that first. I'm on the Transform tab of the ribbon, and I'm going to find the feature called Split Column. And I'm going to choose to split the column by a delimiter. Now, I wish I had a simple delimiter in here, but I don't. I have a rather custom delimiter of a space in there. So I'm going to need to choose the custom option from the delimiter drop-down menu. And then I'm just going to type in space. And I'm going to choose to split this at each occurrence of the delimiter. You'll see that I actually have that going on multiple times in this column here. So I'm going to want this to work for every single occurrence of this particular delimiter. And I'll go ahead and click OK. Now's a good time to pause the video and make sure that you have chosen to split by a delimiter, a custom delimiter, space. This looks pretty good. Now all I'm going to want to do is rename my columns so that they're actually named appropriately. So maybe I'll want this to be category name. The second column should be year. And then I'll have quarter. And then this is month. And for value over here, this is profit data. So I am going to call it profit. Okay, I'm feeling pretty good about this, so let's go ahead and save this query. Now, I don't actually want to close it, but I do want to apply it. So I'm going to click on the Close and Apply drop-down menu and choose Apply. Now, there's a benefit to having your original data all be structured exactly the same. It just so turns out that the other data that I'm going to need to fetch, I already have profit, but I'll need the sales and returns data. Once I query that, it has all the exact same steps. I don't need the totals column all the way on the right-hand side, and I needed to unpivot all my data except for the labels. Then all I did was split my year, quarter, month column into 3 separate columns. And then I just renamed these headers here. So I'm going to need the exact same steps in the other queries I'm going to issue right now. However, if they're going to be exactly the same steps, then why repeat all that work? On the Home tab of your ribbon, you'll see a command called Advanced Editor. If you open up the Advanced Editor, you'll actually be able to see the M script that has been used to achieve this querying that you've done. Now, if I want to take all of the querying changes that I've made already, all I need to do is just select the appropriate query steps here. Now, you might think that you could copy all of this data here, but you actually can't because the first item here talks about where to get the information from and then what sheet to actually get there. Last time we got profit totals, but this time we're not going to want to do that. After that, Power Query always transforms the data into a table. And then following that, you'll start to see the commands that you actually applied. So the first thing that we did is we removed the top rows, then we removed some columns, we promoted some headers, we unpivoted the columns, split columns by a delimiter, and then there's some more information about transforming that into a table style there. And then, of course, we did rename those columns there. So the steps that we actually took, we started with this hash sign, remove top rows. What I'm going to do is I'm going to copy everything from that all the way to the bottom. I'm just going to highlight it like this, and then I am going to use my Control-C shortcut on the keyboard to copy that. Once I've copied this, you can either place it in a text file if you want to keep it forever, or if you're just going to do this and just run it a couple of times right now, you can actually just keep it on your clipboard and do it right now. I did copy that. I'm going to go ahead and click Done. And then I'm going to issue another query from a new source. So I'm going to start to query those other two tables that we didn't grab last time. I'm going to start with the New Source button here, and then I'll click on Excel. I'll choose the competitor report. But this time, I'm going to choose one of the other tables here. So I already got the profit totals. Now I'm going to grab the returns totals, and I'm going to click OK. Now, before I do anything in here, I already have all the steps I need. So I'm going to go straight into the advanced editor. All I'm going to do is remove this last line here that says in. Just going to remove that and paste my data. Now, there's one thing that I might not be totally aware is going to be a problem for me. In the last step, I removed the previous statement that said in, hash, and then there was an instruction at the end of that. What I might not be aware of is that each one of these lines of mscript, all the way at the end, if there's going to be another line after it, they all need to have commas there. Because this line right here didn't actually have anything after it except for the in statement, this line, the change type line, doesn't currently have a comma at the end. So you'll need to go to the end of that column there, go all the way to the end, and then just make sure to put a comma in there. And then you should be good. Go ahead and click on Done. And that looks pretty good. The one thing I will need to do is make sure to change the title of this column to Returns. I can either do that by just changing it manually here, or you can go into the advanced editor, find the line where you renamed the header or renamed the column, and you can just go and find the statement that currently says that it's changing it to profit and change it to returns. Looks pretty good. Now I've just got to do this for the last one. First, I'm going to apply this. Just being safe. And now I'm going to start with a new source from Excel, competitor report. And I'm just going to do the last table, the sales totals. Click OK. Go into the advanced editor, remove this, and paste it. I'll also go to the end of the previous line and put a comma in there. And then maybe if I'm really savvy, I'll go over here and change the renaming of that column from profit to sales. And click Done. If you haven't done so already, now's a really good time to pause the video. Make sure that you have completed the first query on your own, and then after that, you will want to copy the mscript in the advanced editor. Now remember, you will need to copy the mscript after where it says hash changed type, table transform column types. After that statement, you need a comma at the end of that statement, and then you can go ahead and paste your code at the end. You'll want to make sure that you only have one in statement, and if yours looks like mine, you should be good. Go ahead and click on Done. Now in this last example, we were able to open up the advanced editor and take a look at some script that you might not already be familiar with. This script that you'll see back here is referred to as M. M is the querying language that we use with Power Query or with the query editor here in Power BI. Now, if you haven't looked at M before, it's going to look a little bit foreign to you. And so we want to take a couple of minutes just to familiarize ourselves with some of the very simple basics of M. If you want to get more involved in M, I highly encourage you grabbing a book called M is for Data Monkey. It's a really well-reviewed book about the M language. For our purposes, we're just going to learn enough of the basics to be able to perform a simple operation. M is a case-sensitive query language. It uses functions, and with each function, or with most of the functions, you can specify a type for that function. Now, each of these functions, much like the functions in Excel, are going to need particular arguments to be specified in order for the function to be able to process. Down here at the bottom where it says make a list of dates, this is where we have the example of the function that we are actually going to use. And let's talk about why we're going to do this today. In a previous video, we have discussed the benefits of creating a calendar table or a date table. And we actually created an entire date table, but we did that using the data modeling engine, or if you're in Excel, that would be the Power Pivot engine. As neat as it was to be able to create that, it has a couple of limitations. Namely, every single time you want to create a calendar table, you're going to have to create it from scratch. But as we already know, with M, we can easily copy and paste M in a new file, in a new place, on different data, and it will perform that entire operation very quickly, like we just saw in the last example. So what we're going to do is we are going to take the knowledge that we have about calendar tables, and we're going to learn how to create them much more efficiently. If we create them with M, the very first time that we create it, we still have to create the entire thing from scratch. But every time we want to create another calendar table thereafter, all we have to do is copy and paste the M script, and it's really fast. The particular function that we're going to be using to create this calendar table is the list function. So you'll see the list function right here, and specifically, we're going to be listing dates. This List.Dates function has 3 different arguments. First of all, you have to determine when you want that calendar to start, how long you want that calendar to be, and when you're specifying how long you want it to be, are you talking about days, hours, minutes, or seconds? So once we use this function to get us started, we can then use a couple more familiar looking functions to create all the metadata that we need. In order to issue a brand new query, we're going to want to start with a new source here. And this time, we're actually going to issue a blank query. That's going to allow us to start pretty much completely from scratch. So we're going to want to click on New Source and then go down to Blank Query. Now, it looks pretty empty so far. We need to use our List.Dates function in order to get some dates started that we can work with. I'm going to start with an equal sign, just like the functions in Excel. And then I will name the function that I'm going to use, which is called list. And then I'm going to put in a dot and dates. That specifies what kind of a list I want to create. And then I'm going to open up my parens. Now, in Excel, we were able to put in the date function, and that allows us to transform a particular day, like you and I think about it. Now, in order to type in a particular day here, I'm going to have a little bit of trouble if I try typing in something like 1,1,2014. As we saw in the last example of calendar table, our program really doesn't want to recognize this as a date. Our program wants the serial number for that date. I have no idea what the serial number is for January 1st, 2014, so I'm going to use a date function to do that. Now, in Excel, when we did the date function, we just created a date function like that. But in M, it looks more like this. Hash date, make sure to be lowercase here. Remember, M is a case-sensitive querying language. And then I'm going to use this function to take my inputs of year, month, and day, and it will transform that into an actual serial number. Now, let's just start with something basic. We've already determined when our calendar is supposed to start, January 1st, 2014. Let's just say we wanted 10 days. We could then type in 10 as the duration, and then the third argument is just specifying how long each one of those 10 things are. Is it a day long? Is it an hour long? A minute, a second long? So I'm going to use this duration function to just say, yes, it's a day. And this is how we notate that. 1, 0, 0, 0 for all the other alternatives. I've closed out my duration function, but I have not closed out my whole big List.Dates function, so I'm going to go ahead and close that out as well. And now's a good time to pause the video. Make sure that yours matches mine, character for character, and then go ahead and hit enter and confirm that it works. So this is pretty good. It worked. However, what we really need to do is get every single day from January 1st, 2014 through the end of our time period, which is December 31st, 2016. I have no idea how many days that is. I don't want to count and figure it out. I suppose I could go over into Excel and just subtract the days from each other, but I could just as easily subtract the days from each other here in Power Query. I'm going to use a function called duration.days. This is going to allow me to calculate the difference between two different dates. So I'm going to take my last date, which is December 31st, 2016. And of course, I don't know what the serial number is for that, so I'm going to use my date function again here. And then we'll say it's 2016, December 31st. And we're going to subtract from that January 1st, 2014. That should give me the number of days between those two dates. Now, the only thing is that this subtraction right here is actually going to end up being 1 day short. So you have a couple options. You could either add one more day in here, or what a lot of people do is they just skip one more day ahead. So they'll just make it easy for themselves and go in and say 2017, 1/1. That'll make sure that we actually have all the days that we need. Okay, I'm going to want to make sure to close out my duration.days function here. And then I'll go ahead and hit enter, and I should have all the days in here. Last thing I'm going to do here is actually convert this to a table. Now you'll see in the ribbon on the upper left-hand side, I now have a button that says convert to table. So far, this is not actually a table of data. This is just a blank query with one list function right there. So I'm going to go ahead and click on convert to table. And I'll choose, I don't have any extra columns. I don't need to select or enter a delimiter. I can just go ahead and click on OK. And now I have this really good list of dates here. I'm going to rename my very first column to date key. Make sure that you do this as well. Rename your first column to date key. Okay, come on back and we'll add the metadata. Now, of course, this is not going to be a complete calendar table if I only have a list of dates. I'll need to also create all the matching metadata that I'm actually going to want to analyze by. I'll start by creating a column that just lists the year. Find the Add Column tab of the ribbon in Power BI. And on the left-hand side, you'll see a command that says Custom Column. I'm going to go ahead and click on that. We're going to call this Year. And here's how the M script is going to be used to create all these columns of metadata. The function that we need is the date function. Specifically, we need it to extract the year. I'll open up that function. On the right-hand side, I actually have the other existing available columns that I could use over here, and I'll just double-click on the column that we already created called date key. I'll close out my function here. Now's a good time to pause the video and make sure yours looks exactly like mine, and then go ahead and click OK. We're going to need to create quite a bit of metadata, and so I'm going to put up a slide that's going to have each one of the formulas you'll need. Here's a list of all the columns of metadata that you want to have in your calendar table. Now's a good time to pause the video and add all the metadata that we want in our calendar table here, and then come on back and we'll keep going. All right, well done. That may have taken a little bit of time, but it was definitely worth it. I'm just going to rename our table here, and I'm going to call this our DATESM. Okay. Now, I can either click on Close and Apply or just Apply. I'm going to click on Apply because we're still going to have a couple cool things that we want to explore back here in the query editor. But before we move on, I just want to impress upon us how cool it is that we've set this whole thing up. If we now want to go into the advanced editor, we can simply copy all of this M here and just paste it anywhere else that we want this exact same calendar table. For instance, let's say I want to get a calendar table in Excel. What I can do is I can copy all this script that I've just created here in the query editor. And as we've discussed in prior videos, the query editor here in Power BI is almost exactly the same as Power Query in Excel. So I could go ahead and open up Excel if I want to. And for this tutorial, I'm just going to land in a blank workbook. And what I'm going to do is I'm going to go over to the Data tab and find my Get and Transform command group. In previous videos, we've discussed that this command group right here is also called Power Query. Now I'm in 2016. If you have a prior version of Excel, then you will have needed to download the Power Query add-in. If you have the Power Query add-in in one of those previous versions of Excel, then it doesn't show up as a command group on the Data tab of the ribbon. Instead, you'll see that you have a tab of the ribbon called Power Query. Either way, I'm going to choose to issue a brand new query from another source, from other sources, and at the very bottom of that list, I'll see a blank query. Now, just like last time when we were creating this query in Power BI, the very first option I have here is to start with a function that will create the list. And I could indeed start this whole thing over again. But we've done all of the work and we copied all that work. So now all we need to do is go into the advanced editor and simply select everything that's there, remove it, and paste. Now that I've pasted all that great M script that we just spent so much time creating, go ahead and click Done. And now I have that whole calendar right here in Excel. So anytime I need to add a calendar to either Excel or to Power BI, the great thing is that I only had to do that once. So now I know that in the future, if I ever need to get this calendar table in any other file, I've already done all the work for it. All I have to do is just copy that exact same script and just paste it right in here, and now it's done, just like that. I've returned back to Power BI to discuss our last cool feature that we're going to learn about Power Query in this course. We're going to talk about creating your own custom functions. We've created this really great calendar table. However, in the future, I might not always want to start my calendar from January 1st, 2014, and I might not want to end it on December 31st, 2016. So I want to build in some flexibility here so that I can enter in a start date and an end date, and this calendar table will automatically populate with whatever I choose my start date and end date to be. Creating a function in Power BI is a little bit easier than it is in Excel. We're going to start by going into the advanced editor for your DATESM table here. So I'm going to click on the advanced editor. To add the little bit of coding necessary in order to convert this query into a function, a custom function, all you have to do is start by opening and closing two parens, put an equal sign, and then your greater than sign. Now when I click on Done, notice that this actually gets converted to a function. Look, my symbol has changed and everything. Now all I need to do is create some parameters that I can use for my start date and end date. On the Home tab of the ribbon, you'll see a command right here called Manage Parameters. If I click on Manage Parameters, I can easily create a new parameter. I'm going to start by creating a parameter called Start Date. Now this is going to be a date data type, but I'm just going to plug in the starting value as 1/1/2014. And I'll click OK. Now I even have a parameter for my function. Now, my function is going to be ready to run at any time. If I click this Invoke button here, it's going to create a brand new table. It's just going to run that entire function. So it's just going to invoke that entire function again and essentially create a double of my calendar table. So I'll just go ahead and click on that to test it out. And bam, now I have something called invoked function. So if I wanted to, I could come in here and I could rename this my current dates or whatever I wanted to name it. And then I could keep that as my date table. However, we discussed using a parameter inside of a function. So I've created the parameter called start date. Now I actually have to go into my function and put my parameter in there. And here's how we do that. In the advanced editor, I'm going to need to start by passing the parameter through the parentheses that initiated my function here. That little programming is actually meant to hold parameters, and you could put as many parameters as you want in here. I'm going to say, okay, I'm going to use a parameter called start date, so be ready for it. Now I'm actually going to go and find the locations where I've hard-coded January 1st, 2014, and I'm going to remove all of that. And I'm going to put in start date. And I could find every other time I need to use this as well. In a real-world situation, you would also probably want to apply this to an end date, so you would create another parameter and use it for end date. But we're just going to start with our very simple little example here. So I am putting my start date in there as the starting date for my calendar, and I'll go ahead and click on done. Now you'll see that I actually have the ability to type in a start date here. And I'll go ahead and type in 2014, that exact same date, because that's actually the dates that we need for our data for the rest of the class. And I'll click on invoke. Now I have a brand new calendar table that is starting on January 1st, 2014. Okay, let's clean this up a little bit here. That was pretty cool, but I just want you to take a moment and make sure to delete any extra versions of this calendar. We only want a single calendar, and we'll call it dates. And we only want one dates table when you're done. But in the future, now you know, you can always just plug in a new start date. You could plug in an end date very easily and use those parameters. Great. Now that we have all of our dates in here, let's actually get back to some fun analysis. I'm going to go ahead and click on Close and Apply here. And you may notice that on the right-hand side, your dates table has actually been renamed to Dates2. That's totally fine. For the rest of the course, though, you will want to make sure to use just a single one of these dates tables, and you'll want to make sure that it's related to your data. Now that we have these great dates tables, we're actually going to start to take a look at date information and using some of the time intelligence features in Power BI. In order to do this, you'll want to create a brand new fresh slate here. We're going to get a fresh canvas by creating a new page. We're going to go ahead and build a couple of tables that are going to be the exercises with which we create our time intelligence functions. Now, I do have the Dates2 table that we created with Power Query, or the query editor engine here in Power BI. However, I'm not going to use that. I could, but I would need to go in and relate the table to the rest of my data. And I do still have this dates table that we built using the data modeling features. So I'm going to go ahead and use these just out of convenience. Let's say I wanted to be able to analyze some information about our years and about our months. I'm going to grab my year field, drag it and drop it on the canvas. And then I'll also do that with my month name field. Now, this is showing up as a clustered column chart, but for the next few examples, we're not going to use that very much. We're going to use this matrix table visual instead. I'm going to switch to the matrix table, and now I can actually see my data segmented out by year and all of the different months in each year. Now let's start to do some analysis. We are going to take a look at our total sales information here. I'm going to move my table to the left-hand side. We do have total sales information. We have already created a measure called total sales, and it is on the fact sales table. So I'm going to go ahead and open up the fact sales table, find my total sales measure, and I'm going to drag that and drop it in my matrix table as well. Now, this is pretty good. However, if I wanted to start to be able to see something like a running total or a year-to-date calculation, I don't really have anything built in here already that can accomplish that. We need to talk about some concepts of how data is presented, whether it's here on a table or whether it's in any other kind of a visual. There are some intrinsic filters that are being applied simply by the nature of organizing data in a table or in a visual. For instance, my table is segmenting my larger data set to just analyze 3 different fields. So it's looking at total sales information. I have a column of data in the fact sales table that contains the sales data. And then I am using this category here, the year 2016, to segment out that entire collection of sales data for just a particular year. And then I am drilling down a little bit deeper and also starting to segment it out by month. So if you think about it, there are intrinsic filters that are being applied here by the table. So this total that I'm seeing right here, that is not a total for all my total sales. It's a total for just 2016 and just January. Now, if we wanted to create a measure that provided a running total, we would need to essentially negate the existing filter here on the table. We would have to say, no longer filter for just January. Let's say we were figuring out the running total for February. In that case, February would include the totals of both January and February, because this is a running total now. This is a year-to-date function, which means that it is continuing to add up each previous month. All right, so now I have to take this one little spot in my table and somehow get my table to understand that it needs to ignore the February only filter, ignore that filter, and instead include February and January and add it up and place it in that one little spot. Essentially, what we are doing is we are intentionally negating implicit filters on the table. So essentially, we're going to create a function that will still add up the total sales, but this time only if that sales have to do with January and February. Now, we've already seen a function that allows us to sum if or average if here in Power BI, and that function was called calculate. Now, we talked about how this function allows you to put in a measure that you've created, like sum, and then you can apply a filter criteria or many filter criterias. This helps you build your own custom sum if, average if, or what else you want. Now, this if criteria is actually just a filter option. But what's really cool about the calculate function is it can actually use this filter argument here to negate existing filters. So instead of saying just February here, we could say if it's January and February. Now, building this function on your own could be a little bit cumbersome, so it's nice that we've already had a few functions designed for us that are going to really nicely take care of the job. We have year-to-date functions, and then you also have month-to-date and quarter-to-date functions that you can use as well. These functions look like this: dates, year-to-date. Now, this is only used as a filter criteria for your calculate function. So essentially, this is what we consider a helper function for your calculate. So we're going to go ahead and build ourselves a measure that's going to be able to add up the total sales, but take into account the actual year-to-date information. I'm going to right-click on our fact sales table and choose to create a new measure. Now, I'm going to call this measure total sales year-to-date. And maybe I'll actually put a little space in there. That's going to help me. After I've created 3 different ones, it'll help me to have that little space in there visually. All right, so this is going to be based on my calculate function. And it's just going to use the normal total sales measure that we've already created. And the second argument, the filter criteria for your calculate function, is going to be the dates year-to-date function there. And we will tell this function to take the dates that it normally uses, which would be the date key. And our date key is in our dates table. And you'll see that you have a lot of specific options that you can use, but this is pretty good. We can close out this function here. Now I've closed out the dates year-to-date function. I'm going to need to put another parenthesis on the end to close out my calculate function, and then I'm going to go ahead and hit enter. Let's see if it worked. I'm going to find my total sales year-to-date, drag it and drop it on my visual. And there we go. That looks pretty good. If you haven't done so already, now's a great time to pause the video and create a new function. We're going to call it total sales year to date. And the calculate function is going to be based off the normal total sales measure that we use, except for an additional filter criteria that allows it to take into account that running total. And for that, we use the dates year to date function. And we chose to negate the existing filter of February or March or whatever it is there, and include all of the dates for the entire year. There's a whole collection of really neat time intelligence functions in Power BI. We're going to focus on a couple of them. We've already talked about dates year to date. You might also want to create additional measures for quarter to date, and then you could also do month to date, but keep in mind, you're only looking at your month information. So if you actually want to see your month to date function working, you will need to take some data that is more granular than months, like maybe weeks or something like that. And then you'll actually be able to see your month to date function in action. Now's a good time to pause the video and create additional functions based on this calculate year to date, except you're going to create ones for quarter to date and for month to date. Go ahead and give that a shot and come on back to see if you got it right. When you've created the quarter to date and month to date measures, go ahead and also put them on your matrix table here so you can see the results. With year to date, you'll see that the running total continues adding up until it actually gets to the end of the year, which makes sense because that's a year to date. For your quarter to date measure, you'll notice that that only continues accumulating value until the actual quarter is over. And then in the fourth month, for instance, in April, you'll see it reset. In month to date, you'll see that each month actually looks like the original total sales looked, and that's because we're not seeing granular enough information to actually see month to date start to add up. What you want to do is start to segment out your information by maybe weeks or something like that, and then you'll be able to see it in action. If you'd like to compare your measure to mine, here's the month to date function that I created. And then I'm going to click on the quarter to date function as well, so we can take a look at that one as well. Now's a good time to pause the video, make sure that each one of those look correct and your answers look reasonable, and then we'll move on. For the next couple of exercises, I'm going to go ahead and remove the year to date, quarter to date, and month to date measures that we've already made. In this next example, we're going to take a look at a really handy function, another helper function of calculate, but it's one that allows you to go forward or backward in time. Now, let's talk first about why we might want to do this. If you wanted to figure out the growth or change over time from this month to the previous month, you're going to need to be able to include the previous month's data right alongside the current month's data so that you can actually subtract them together. So we're going to need to create a measure that is actually able to look to a previous date, or a previous month, or a previous quarter, or a previous year. Now, we probably don't want to make this function to just use the function's result all by itself, but we might want to use this function to calculate change over time. We can only create change over time calculations if we can simultaneously consider a current value and a previous value and calculate them against each other. For instance, if you were calculating percent change over time, you might take the previous value and subtract from it the current value. And then the result of that could be divided over the previous value, and that would give you a growth rate. There are a couple different ways to calculate a growth rate, but most of them require you to be able to take into account a previous value and a current value at the same time in a single calculation. So first, we're going to need to be able to create a measure that can actually look at a previous month or previous year's total sales. We are going to use calculate for this. Calculate, once again, coming in handy. I'm going to right-click on my fact sales table and create a new measure. And I'm just going to start by saying this is going to be total sales for the previous month. Now I am going to use the calculate function to do this. And it's going to calculate the normal total sales measure, except we're going to disrupt the existing filter, stop looking at the existing current filter, and we're going to use the DATEADD function to look forward or backward in time. Now, the DATEADD function just has 3 arguments. First of all, I need to tell it what dates it's going to be looking at. So I can either say use the dates from the fact sales table, or if you think about it, the fact sales table is actually retrieving that information from the dates table. So I'll probably use my dates table since it's more parental in the hierarchy. I'll say look at the dates, date key, and then I want it to go back in time by -1. That's going to go backwards in time by 1. And then I need to specify one what? 1 day, 1 month, 1 quarter, 1 year. I'll say 1 month. And I should be good. Placing this on the same visual right next to your normal total sales measure should display information from the previous time period. So I should be able to see February showing up there. That should be the same actual total sales amount from January. So February in my total sales previous month should be equal to January in my regular total sales. Now's a good time to pause the video and make sure that you have created this total sales previous month calculation. Okay, now that I can actually look at the current month and the previous month in 2 separate measures, now I can use those measures in a calculation themselves. So I'm going to create one more measure here. I'm going to create a new measure. And we're going to call this % change from the previous month. And maybe I'll shorten this up a little bit. Now, my % change from the previous month is simply going to be my total sales for the previous month minus my current total sales, which is just total sales. I'm going to want to subtract these from each other, and then after I get that result, I'm going to want to divide it over the total sales for the previous month. Of course, if I just do this with a slash right now for the divide sign, I'm going to have a PEMDAS problem. If you remember your order of operations from school, we should put those parentheses in there to get this calculation to actually happen first. And then I'll go ahead and say I want to divide it by the total sales for the previous month. Now we should be able to go ahead and execute that and add it onto our visual. Looks pretty good, but I'm going to format it so it actually shows up as a percentage. And that should look a little bit better. I can go ahead and remove my total sales for the previous month calculation from my matrix table because I actually don't need that for my end users to be able to see that. That would be a little bit confusing for them. I really just created that measure in order to be able to use it in this % change previous month calculation. If you haven't done so already, now is a great time to make sure that you have completed not only the total sales previous month measure, but also the % change previous month measure as well. And then go ahead and throw it onto your visual and see how it looks. For these next couple of examples, I'm going to remove all the existing measures that we have from our table, and I'm just going to leave the labels for year and month. We're going to use a function called first_date, and what it's going to do is detect the periods that you are using on your table, and it will be able to populate for you the first date of that month. Now, it also works for quarters, it works for years, it works for weeks. It's great. Let's go ahead and build this. I'm going to right-click on my fact sales table and create a new measure. We're just going to start by calling this first date period. So of any given standard calendar period, it will be able to figure out the first date of that period. Now this function is really easy, and it's a standalone function if you want to use it by itself. I'll just type in first date here, and there's my first date function. Excellent. And I am just going to use the date key from the dates table. If I drag this and drop it on my table, I'll be able to see the very first date of each period populated there. Pretty cool. This comes in handy, especially if you're wanting to do a calculation like first 15. Maybe you want to know what the total sales were of the first 15 days in every period, because you want to be able to analyze that. In that case, not only are we going to have to detect what the first date in each period is, or in each month is, but we're also going to need to be able to perform a arithmetic calculation while expanding our filter criteria to include the first date, the second date, the third date, etc., all the way until we get to the 15th date. Now, we are going to use the calculate function to do this, but we're going to use a helper function of calculate called DATESBETWEEN. And what this function is going to do is allow us to include all of the dates between this first date of the period and the 15th date of the period. What's nice is that the DATESBETWEEN function will allow us to collect all of those days together that we want to be able to analyze, and then the calculate function can actually use those dates as the filter criteria. So let's go ahead and create a new measure here. I'm going to right-click on Fact Sales Table, create a new measure, and we're going to call this Total Sales First 15. Now I am going to use my calculate function for this. And my calculate function is going to be using our regular total sales measure. Now for the filter criteria, I'm going to use this great function called DATESBETWEEN. Now, the DATESBETWEEN function only has 3 arguments. It just needs you to tell it what dates it's going to be using. So in our case, we're just going to use the dates key information from our date table. And then all we need to do is tell it what the starting date is and what the ending date is. Now, if we really wanted to do this and hard code it, we could say, okay, calculate this for the first day of January all the way through the 15th day of January. But eventually, we want to be able to use this calculation for any of the other months as well. We're going to use our cool first date function to do this for us. So it's going to detect the very first date in that particular period, and that will be the starting date. And the ending date is going to be the first date. I guess actually in our case, it's going to be the first date plus 14. Okay, I need to close my parens for the DATESBETWEEN function, and then I'm also going to need to close out my parens for the calculate function. Okay, let's put it on our visual and see if it worked. Looks good. This looks pretty good. Now, let's say we want to be able to check out this great analysis that we've done for our own company, but we also want to compare this to the information for our competitor. Now, we pulled in some competitor data earlier in today's session. We called those tables profit totals, return totals, and sales totals. We could easily have renamed those to be a little bit more explicit and say something like competitor profit, competitor returns, and competitor sales. But for now, you and I know what they mean, so we'll leave it as is. If we want to be able to do any of the analyses that we have already done for ourselves on our competitor data, we're going to need to relate that competitor data to the rest of our data. So let's start by doing that. We're going to go over to our relationships mode. And in relationships mode, you may need to click on this little command down here that will expand your view so that you can see all of your tables in there. Here's the information for our competitors: profit totals, return totals, and sales totals as well. We also have a couple of other tables over here that we're not going to be using in any further examples. so I'm going to move them over to the side. Lucky for us, in all those time intelligence functions that we've already created, we reference the dates that are on the dates table. Each one of those functions would also have worked if you reference the dates that are on the fact sales table. However, in a few minutes, we're going to be taking our dates table and using it to create a connection to our competitors' data. By nature of relationships, any kind of a filter that you apply to a parental table like this, we refer to them as lookup tables. Any filter that you apply to a dates table like we did with our time and date, like we did with our time intelligence functions, that same filter will flow downstream into any downstream tables like fact sales. So this is convenient. We've created these measures and they're on the dates table. So in a couple minutes, when we now relate our dates table information to our competitors' data, it means that those exact same calculations are also going to be usable with our competitors' data. Let's start by trying to take our date key information and relate it to the sales information from our competitors. First of all, we're going to notice a bit of a problem in that in our dates table, we have a date key, but there's no date key over here in our competitors table. So what some people might think to do is to take a year or month and try and drag and drop that to create a relationship with that. For instance, if I tried to grab month number and relate it to month over in our competitors' data, we're going to have a problem because you can't create a relationship between these two columns because one of the columns must have unique values. So the problem that we're having is that each month number is listed multiple times in the dates table, and it's also listed multiple times in the sales table. Well, if I have the same value showing up multiple times in each table, how is Power BI supposed to understand which version of January is supposed to connect to which version of January over on the sales table, or February to February? So the problem I'm having here is that I have multiples in each one of these tables. What would solve this problem is if I had a value in my competitor table over here that didn't repeat multiple times, such as a date key. Then I could relate the date key to date keys over here in sales totals. The only problem is that the data from my competitor isn't that granular. The data from my competitor only gets as granular as months. We have years, quarters, and months. We don't have weeks, we don't have days, and we certainly don't have hours and minutes. So what we're going to do to deal with this is cover a couple of complicated relationship strategies. These are going to help you handle the different kinds of complicated relationships that you will naturally run into as part of your Power BI career. In our scenario here, because we're having a granularity discrepancy between these two tables, that's what's really causing our problem. What we can do is falsely create some more highly granular data over here in our competitor table. If I create something that looks like a date key, then I'll be able to relate it to the date key in our own data. So let's go ahead and do that. I'm going to switch back to data mode so that I can look at the actual data in our competitor's sales table. And I'll go ahead and find our sales totals, and we'll see that we just have year information, quarter information, and month information. What we're going to need to do is falsely generate some date keys for each one of these months. I'm going to go ahead and create a new column, and I suggest you follow along with me. This new column is going to populate a date key for each one of these months. Now, a typical date key should have the year and month and day, basically meaning that it is an entire date key. Now, we already know of a cool function that will do this for us, and that is the date function. I'm going to go ahead and name this date key, and then we'll use the date function. For the year of the date function, I can actually use the year that is in this particular table. We have a year column right here in our table. I'll choose sales totals, year. For the month, we have the same. Sales totals, month. Now, for the day, it's totally up to you, although I usually choose the very first day of the period. So I'm always going to choose day 1. Now, when we execute this, you should notice that date keys are now being populated in here. Now all we have to do is go back to relationships mode and now use these date keys that we've generated and connect them with the date keys on the dates table. I'm going to grab the sales totals date key and drag it and drop it on top of the dates table date key. There we go. Now I should be able to take our sales total data from our competitor and compare it side by side with our total sales in our own data. Let's go back to report mode in order to take a look at this. I'm going to take off the 2 measures that we already have on here from the last example. And instead, I'm going to find our total sales measure, which looks at our own data. And then we'll go down to our competitor data, sales totals, grab the sales information from here, drag it, and drop it onto our visual as well. If we look at this data in the visual, we really want to be careful that the sales information doesn't go into rows, but that the sales information goes into values. Now, this is another hiccup that has come in from the way that we actually retrieved this data. And the problem that we are seeing here is that this numerical data is being treated like text. So we're going to need to fix that. Going back to data mode, let's go ahead and isolate our sales column in our sales totals table. And you'll notice up here that the formatting of this particular data is coming in as text. That has to do with the way that we retrieved this information. We can go ahead and just change it really quickly here and say that this should be a decimal number. And I'll go ahead and click yes on this warning. And now let's go ahead and look at our visual and see if it looks a little bit better. Now I do have a minimum of sales being calculated, but I can go ahead and fix that just by clicking on sales here and say that I want to revert that to sum. Now we can easily compare side by side the total sales for us and the sales for our competitor. And I can turn that into the standard currency format also. Okay, looks pretty good. If you haven't done so already, make sure that you have generated a date key column in our sales totals table. Then make sure that you have related that information to our own dates table. Then you'll want to grab that sales data and place it in a visual. And if you run into problems with the sales field not showing up in the right area, then you might need to go back and reformat that sales column so that it's actually being treated like a number. When you've done that, come on back. For the next example of a complicated relationship, we're going to go ahead and generate some extra data. So what we're going to do is we're going to take a look at some information on our fact sales table about when a payment was actually due. So let's say when each transaction happens in our fact sales table, there's a date key associated with that data. But we want to start to create payment due dates, and we want to put that in our fact sales table as well. Let's go ahead and just generate a little bit of extra data for this next exercise. We're going to want to switch to data mode and take a look at our fact sales table. Now, we do already have our date keys, but we're going to take a look at a scenario in which we don't want to analyze just by date key, but we also want to be able to analyze by a due date, a payment due date. Let's go ahead and create a new column, and we will generate a column of payment due dates. I'm going to go ahead and call this column payment due date. And that's going to be pretty easy. It's just going to be our fact sales date key plus 15 days. If you haven't done so already, pause the video and make sure that you've gone over your fact sales table and created a new column. Call it the payment due date, and it's going to take the existing date key and add 15 days to it. Now, what we're going to want to do is we're going to want to be able to periodically analyze not by the date key in the dates table, by the payment due date. Now, if we switch over to relationships mode, let's take a look at what this is really going to mean for us. I'm going to grab my fact sales table and move it up a little bit. Now, we do want to be able to analyze by the date key to date key relationship that we have here, but we also want to be able to do an analysis using the payment due date column that we have now created in here. If we create another relationship here, watch what happens. I'm going to grab payment due date and drag it and drop it on top of date key in the dates table. When I do this, if you look really closely, you'll see that a secondary relationship was created here, but it's a relationship with a dotted line. That means that it is an inactive relationship. Now, if I wanted to, I could make this relationship active if I really wanted to all the time, but I don't really want to do that because most of the time we're going to use the date key relationship. It's just that every once in a while, I do want to be able to use the payment due date relationship as well. So what I can do is create a measure that specifically uses this relationship that we've just created. Let's go ahead and do that. All right, I'm going to switch back to our report view so that we can see this in action. Let's take out the information for our competitor because we're no longer analyzing that. We are, however, analyzing our own total sales information. What we're going to do is we're going to create a brand new measure here in our fact sales table using our friendly calculate function. The calculate function is going to be able to use another helper function called use relationship, and this is going to allow us to actually use that inactive relationship there. Let's go ahead and create a new measure called total sales by due date. And we're going to use our calculate function here. We're going to do our normal total sales calculation, but with one small change. We're going to use the relationship that we've just established. Here's how you use this function. We're going to specify the column on the fact sales table that actually has the data used in that relationship. So that happens to be that column that we created a few minutes ago called payment due date. And that connects to our date table, and it connects straight to the dates key on there. So that's it. That's all the use relationship function requires. It just requires you to name the columns in both tables that actually create the relationship there. I'm going to close out the parens for my use relationship function, and I'm also going to close them out for my calculate function. Go ahead and execute that. And then let's put it in our visual to see it in action. Looks pretty good. If you haven't done so already, try this out. In your fact sales table, create another column of data that populates the due date, which would be the date key plus 15 days. Then create a relationship between your payment due date and your dates table. Then we created a measure called total sales by due date that uses a calculate function with the use relationship helper function. Go ahead and give that a shot and come on back. For this last example of complicated relationships, we're going to deal with a problem with many-to-many relationships. Typically, many-to-many relationships are not handled by data modeling technologies very well, and Power BI isn't really an exception for that. We're going to run into a problem here in that we have colors listed on our products table for each one of our products. But when we offer the product selections to our customers, we send them a swatch, and that swatch has all the colors in a particular theme. So we actually pay for swatches by a collection of themes. We really want to know when we sell a product to somebody, we send them a swatch for that entire theme. And we want to determine how many theme swatches are we sending out for each one of the products that contain a color on that particular theme. Okay, this will make a little bit more sense as we go. We're going to need to query a little bit more information for this because it just so happens that our swatch data comes from the swatch manufacturer, and we're going to go and grab the data from the swatch manufacturer. So we're going to go ahead and get data, and this is housed in Excel. And you'll see that there is one more file in your Day 3 work files called many-to-many. Go ahead and open that. And in here, you'll see a table called Colors. Now you'll notice with our colors that we have color themes, and in each color theme, we have multiple colors in that particular theme. Additionally, a single color could be in multiple different themes. We're going to have a little bit of trouble when we try and relate the color names here to the color names on our product tables, because as you can see here, each one of these colors is listed many times. Let's just go ahead and edit this on its way in, because we're going to need to address the problem of our headers here. So let's go ahead and do that real quick. Click on Edit, and in the query editor, we'll go ahead and use our first row as headers. Okay, let's go ahead and close and apply. And let's actually see the problem that we're going to have here. Let's go ahead and just try and create the relationship like normal. If I switch to Relationships mode and go find my new Colors table, I'm going to need to relate the colors information to our product information. I'm going to zoom in a little bit. Now, our product table has color name, and our colors table also has color names. If I try and relate color name to color name, we're going to run into a problem here because you can't create a relationship between these two columns because one of the columns must have unique values. We've already seen this error before, but in the last example, we were able to quickly and easily generate a false ID column or a temporary ID column that served as a bridge between these two tables. However, in this case, we really can't do that because we don't have any ability to ID a color and somehow differentiate it from the different themes that same color might be in. That just isn't going to work. So what we're going to do is we're going to create a bridge table. Now, this query here that brought in our colors table, we can really easily edit that query a little bit to be able to isolate the colors. And if we just take the colors out and remove all the duplicates so that we only have unique colors being listed, then we could easily relate those colors both to the product table and to the colors table. So let's start by actually creating our bridge table here. We're going to need to get back into our query editor. So I'm going to click on Edit Queries, Edit Queries. Now in our colors table, I'm going to right-click on this colors table and choose to reference it for a new query. Now this is going to be my colors unique table. So I'm going to take a second really quick to just rename this really quick. Here are my colors unique. You will also see people name this a colors bridge or just bridge. Now the only thing I need left in here is just the color names. So I'm going to go ahead and right-click on color names and say I want to remove other columns. What that's going to do is just maintain this one column there. Now that we've done that, we will also need to remove duplicates from this column. We can easily remove all the duplicates from this column by simply right-clicking on the column and choosing the command called Remove Duplicates. Now you see that I have a short list of just my unique values. This is going to make for a great bridge table. All right, I'm going to click on Close and Apply. And we'll need to find our colors table. And we might be even so lucky as to have our colors unique table immediately create its own relationships between the product table and the colors table. If not, you can go ahead and click and drag to create those relationships yourself. Now, it all might look all well and good, and it does look pretty good, but I'm not quite in the clear yet. You'll see that if I try and actually create a report that uses the color themes from my colors table and analyzes maybe something like the total sales, or maybe we'll get a count of all of our colors listed there. Let's go ahead and try that out. On the colors table, I'll grab my color themes. And I want to count all the times that a color from each one of those themes is listed in the product table. So, first of all, the problem that I'm having is that my color names are being placed in the rows. That doesn't quite work. So I'll place them in the values instead, and now we'll try and count them. Okay, even when we're counting though, looking at this, I can tell that something is very wrong. And anytime I see numbers duplicating themselves over and over and over again, I know that it's probably a relationship problem. And indeed it is. If I go back to relationships mode and we look really closely, you'll notice that I have a normal one-to-many relationship going from my colors unique table to my product table, as indicated by the icons on either side of the relationship. I have a one-to-many. That's great. What that means is that anything I select on the colors unique table, that filter will flow down to the product table and affect all the results on the product table. So what I need is for colors to flow down to colors unique to flow down to product, but that's not what's happening here. You'll see that I have the one-to-many going in the opposite direction. What this means is that my colors table is not being able to filter my colors unique table at all. Now, it's actually a really easy fix for this. What we need to do is simply create a measure that actually uses this relationship right here. And it's as simple as using our friendly calculate. We're going to need to create a new measure. I'm going to go ahead and put this on our fact sales table because that's where we've been putting all of our measures. And maybe this time we want to do a count of the sales quantity so we know exactly how many swatches we're sending out. So each time a product is sold, the color theme that product color might be on, maybe it's actually on two different themes. A swatch is sent out for each one of those. And so we want to be able to calculate the quantity that's being sold and determine how many swatches we're sending out. So here's our count of sales quantity here. All right, so I'm going to start with my friendly calculate function. And this function is going to add up. We haven't created a measure to count the sales quantity yet. So we're going to add up the fact sales quantity there. Okay, we are currently closing the parens for our sum function, but not for the calculate function. The calculate function's second argument is usually where we can determine a filter criteria. However, it also has this really nifty trick where you can just specify a table that you want to filter by. That's all that you need. So I'll go ahead and execute that. And then we'll grab this measure that we just made, place it on the same visual, and suddenly it works great. I'm going to switch this from being color name to sales quantity so that we're not being confused by that. We'll grab sales quantity and put it on the same visual. Our sales quantity is not working. Our count of sales quantity, or I guess that should be sum of sales quantity, huh? Anyway, our sum or count of sales quantity measure that we made over there, that actually is working, and it's thanks to our friendly calculate function. All right, if you haven't done so already, you'll want to take a moment to create a function that will actually utilize your colors table that you created there. And for that, you will need the calculate function, and you're going to use it to sum, or I guess, let's have it count, since we called it count of sales quantity. All right, so that's going to count the sales quantities that are listed, and then it is going to filter it by the colors table. You'll want to make sure that you are able to actually execute this complicated relationship solution. And then, congratulations, you have now finished day 3 of the Power BI Bootcamp. See you for day 4. All right, welcome back. This is the beginning of day 4 of our Power BI Bootcamp. It is also the second day of our mastering class, and we are going to cover 3 really important topics today. We're going to start by covering some concepts that are going to lead you towards mastery of Power BI and data modeling in general. That is discussing how filters work and the concepts behind how data modeling handles data and filters the resulting downstream tables of data. Following that, we're going to take a look at the utilization of disconnected tables. So why would you want to have tables of data that weren't actually connected to your data model through a relationship? There are some reasons to create tables like this, and we'll talk about what the advantages are. Once you know what the advantages are, of course, you'll also be taking home the reasons why lacks of relationships or unworking relationships also cause problems, which is a continuation of the topic that we discussed yesterday, complicated relationships. And finally, today, we are going to be customizing visuals using the custom visuals that are available in the Power BI online community. And we are also going to be customizing some dashboards so that we can program them for specific use by specific people, and so that we can share them as easily as possible, and a few other mechanisms that are going to allow us to design for consumption. Let's get started. We're going to start with one of the most complex, but one of the most important skills you will want to achieve, and this is a conceptual skill. Understanding how a pivot table or any other visual applies inherent filters. For instance, when we're looking at this pivot table data right here, we'll notice that the grand total is being placed right there. Some of this conceptual stuff is going to seem rather simple, but it's really important to go over, and it will lead to your mastery of data modeling. We have our grand total here at the bottom, but then above that, we have our data sliced or segmented into sections of the data. So if you think about this number at the bottom represents every single sale that is on the fact sales table all together and added together. And then this one single number is being represented as the total of all those numbers. Above this, we are seeing that our data is being segmented out by a particular category. But if you've looked at the fact sales table, the product category information, which is the row labels that you're seeing here, that product category information isn't necessarily on the fact sales table, and it doesn't have to be. That information is on an uphill table from fact sales. Our fact sales table, which is also commonly referred to as a data table because it has all of the transaction and all of the historical figures, it has all of the data on it. It is the most downstream table in our data set, which means that there are a lot of upstream tables that are able to affect the fact sales table. For instance, if we apply a filter on the product table, that filter that we've applied on the product table is also going to inherently filter out the fact sales table. So let's talk about this. When we are creating a visual, and we want that visual to spread out the total sales by product category, how does our pivot table or any other kind of a visual actually figure out what that slice of the data should amount to? The way that it's able to do this is every single cell that has a measure in it is using coordinates from the pivot table or from the visual to determine how it's supposed to slice the information. For instance, here we have a label called audio. That means that the total sales information here is going to be sliced by audio. Audio is on our category table. So our data model must somehow figure out how to take just the audio slice of the category table and send that all the way downstream to filter the fact sales table. And this is how it works. If we select one particular category from the category table, we'll take the example of audio. Audio translates to 3 different subcategories. It has 3 different subcategories. And the 3 different subcategories, if you care, they are Bluetooth headphones and MP3s and MP4s and recording pens. If we slice the category table and then wanted to analyze anything on the subcategory table, all that's going to be left on the subcategory table is items that specifically match the audio category. Meaning, while your pivot table or other visual is processing the calculations that it's going to display for you, it literally, you can think about it like this to make it easier to understand, it literally filters all the downstream tables. And then once everything is filtered, it actually does the arithmetic. So far, we've chosen the audio category in the category table, which has inherently filtered out the subcategory table for only subcategories that have to do with audio. That flows further downstream to send all of those subcategories that had to do with audio down to the products table, which means that the products table is being filtered by all the items that match the subcategories that were left on the subcategory table. So now we just have a portion of our products table left. And then whatever's on the products table can, of course, flow downstream to filter our fact sales table. So the way that this works is once we've actually chosen a slice of our data like audio, it flows down through all of the downstream tables until it lands in the data table, in this case our fact sales table. And then you'll see this bright yellow portion at the bottom is all that's left that had to do with audio. Now that that table has been completely filtered out so that the only answers it sees are audio, now it can actually do the arithmetic. Once that arithmetic is performed, that arithmetic is then presented on the pivot table in that cell where the measure was placed. One more important thing to understand about this is that this means that all of your filters flow downstream. A filter applied to your highest table will naturally flow all the way down into your lowest table, assuming you have one-to-many relationships all the way along the way. You'll see we have a one-to-many here. 1 to asterisk indicates one-to-many, and a one-to-many here, and a one-to-many here. That means that once we are left on our fact sales table, we are only left with the information that was filtered out of our product category table. Once we understand the order of operations or the order in which a measure is processed, then we can start to understand why sometimes things go wrong. When we start to design our own measures in the real world, you're going to find that really often you'll run into a snag or two, and you'll want to be able to troubleshoot that snag. Using this order of operations will help you cure a lot of those snag issues. I'm going to use the visual aids that are on the right-hand side of this slide to demonstrate the order of operations. But remember, even though I'm using a pivot table here, this same principle, all of these principles, go for any visual that you'll use. Our very first item in our order of operations is detecting the pivot coordinates. Now remember, I am using a pivot table, so I'm talking about pivot coordinates, but that would also be true for any other type of visual that you'll use. Let's explain what we mean by coordinates. If we were to just use the example of the measure that is returned for audio for total sales, then the pivot coordinates that we would be looking at here would be audio and total sales, and maybe if I've placed something in the columns, I'll take that into account as well. However, so far I only have a row label called audio, and I do have the measure that I'm using called total sales. After I've detected the pivot coordinates, we now apply those coordinates filters to each respective table, which means that each coordinate actually acts as a filter to filter out a table of data. For instance, in our category table, we had a chunk in our category table called audio. We are now going to slice the category table for just audio, and then of course we know that that filter that's placed there is going to flow all the way downstream, all the way through our subcategory table and our products table and into our fact sales table. And that's step 3. Filters flow down relationships. So we've filtered out audio, and that's flowing all the way down through all of our downstream relationships. Now that we've actually applied all the filters, now we can do the arithmetic. So it depends on what arithmetic we're actually trying to do. In this case, we're looking at total sales, and that total sales information just happens to be in a column on the fact sales table. And so we can actually apply the arithmetic there. It just so happens that the measure that we design sums up the information in the fact sales table, and that's the arithmetic that we're doing there. And then the result is sent back to the pivot table and actually displayed in this one little spot here. It's helpful to think about these order of operations as actually happening step by step in every single measure that you ever create. And then, after it's done audio, it'll move along to cameras and camcorders and complete the exact same process. Now, there's one very important interruption that we can use in this process. After we've actually detected the pivot coordinates, we can stop the process before we actually apply the coordinate filters to each table. There are going to be a lot of cases in which you have implicit filters being applied by either a visual or by a pivot or some other kind of a table here, and you don't actually want it to completely pay attention to just this item. For instance, maybe you were trying to do a calculation that compares just audio sales to the entirety of all the sales. Well, unless all the arithmetic can happen in this one little cell, the arithmetic's not going to happen. So this one little cell here has to be able to simultaneously understand what the total sales are for audio and what the total sales are for everything. But the total sales for everything aren't in this cell up here, they're down here. And so what you're going to have to do is create a measure that actually ignores audio so that it can consider everything. And then it can compare audio to everything. And our calculate function is exactly what does that. This is one of the reasons why the calculate function is one of the most important functions that you will ever learn in your Power Pivot data modeling or in your Power BI data modeling features. We are going to be using the calculate function multiple times again today in order to disrupt existing implicit filters on either a pivot or any other kind of visual. If you haven't already done so, take a moment to open the file called Data Model. That is a Power BI file, and you'll find it in your student files inside the folder called Day 4 Work Files. In Day 4 Work Files, you have a file called Data Model, and this is what we're going to start working on today. In your Data Model file, please go to the page that is called Using All. We're going to use the function called all in order to intentionally negate some implicit structural filters that are placed either in a table or on a visual. For this first example, we're going to want to figure out what percent of all sales is by a particular category. So we'll start with the example of audio. So for audio, we would want to be able to see a percentage that showed the portion of actual audio sales divided over all of the sales for all of the product categories. In order to do this, we're going to have to get this one space in our visual or this one space in our table to be able to simultaneously consider the total sales for just audio and at the same time be able to understand what the total sales is for all the product categories. In order to do this, we're going to need to use our measure called total sales. That will figure out just the one for audio, but we're going to need to create a special measure called total sales of all the products so that we can then divide the regular total sales over the total sales of all the products. So let's go ahead and create a new measure here. I'm going to click on New Measure and create a new measure. Now remember, you can also do this by right-clicking on any table that you want to place your measure in, like fact sales, and go ahead and create a new measure there. We're going to call this measure total sales all product categories. Now this is going to use our friendly calculate function. And our calculate function is simply going to use our standard total sales measure that we've already created much earlier in this class. Except instead of adding an extra filter, we're going to negate an existing filter using the all function. So I'm going to go ahead and type in all, and then all I need to do is just mention the table name that I want to clear all the filters from. Now in this case, my sales information is all the way down on my fact sales data, but my product categories are being chosen way up on my product categories table. So I am going to have a couple of options. I recommend using whichever field you are actually going to be pulling into your visual. Now in these visuals here, we are actually retrieving information from each table where this product category information is located. So the product category name, we fetched that from the product category table. So I'm going to go ahead and just mention the product category table. And I don't even need to specify a field there. I can if I want to, but I don't need to. And I can just say clear all the filters from the product category table. All right, looks good. I just need one more closing parens to close out my calculate function, and I'll go ahead and execute that. If we were to find this measure, which we called total sales all product categories, and place it on the same visual that we already have here, it should look like total sales all product categories is constantly the same number. Now in this case, that's exactly what we want. If you haven't done so already, now's a really good time to make sure that you've created a measure called total sales all product categories. We're using the calculate function and just doing our normal total sales measure, but we're creating a filter criteria, or you can kind of think about it like it's negating a filter. And we're going to use the all function for that. And that's going to remove any filters that are placed on that product category table. And then all we did is we just placed it on this visual so that we could actually see it in action. If you would prefer, you can also place the measure in a card visual. I'll do that for both of the measures that we're focusing on right now. Once you have completed this total sales all product categories, now what we can do is we can actually compare our normal total sales to this fancy total sales that's going to negate any filter criteria and just consider all of the sales altogether. So let's go ahead and do that. We're going to create one more measure and place it on our fact sales table. And we can call this percent of total sales. Now this is going to be our regular total sales measure over the neat one that we just made, which is total sales all product categories. If you haven't done so already, now's a good time to pause the video and make sure that you have created the measure that you see in my formula bar. When you're done, you'll want to take a moment to just switch over to your modeling tab real quick. Click on your measure and just make sure that you format it. Now, if you're getting the gray bars, you can just click on any other measure and click back on your total sales or percent of total sales measure. Sometimes Power BI does that. Hopefully it will get fixed in one of the upcoming updates. All right, let's see what that looks like. Now, it doesn't look very good on my visual here. I'm having a huge problem with this visual, and that is that this is actually a percent series, so of course that number is not going to seem very big. So a percent series, usually you want to place it on a visual all by itself, or alternatively, you do have the option of using one of these column and line chart, combined chart styles, in which case you could put a percent of total sales into the line values, ensures that it is calculated on a secondary axis. Now in this case, this chart isn't very meaningful. I would probably want to put a percent of total sales measure on its own chart all by itself. And then I will segment this by our different product categories, which I have in my product category table. And I'll grab product category name and drop it in there. That might be a little bit more meaningful to us. Put on a couple data labels, and decision makers are going to love this. Let's make this a little bit more interesting. I'm going to delete this visual on the upper right-hand side so I can make a little bit more room for more data in my table over here. Instead of just having product categories in here, I also want to have the product subcategories. So I'm going to go down to the product subcategory table and find the product subcategory name there. Now I am going to need to change the order here because it will put it in third. So I'm going to drag that and drop it. So now I have product category name, product subcategory name, and then total sales. Nothing exciting quite yet. Let's go find the measure that we just made and see if it works with this. If we grab percent of total sales and drag it and drop it in the values field area, you'll see that all of a sudden we start seeing a lot of 100%. So let's kind of break down and see why this is happening. Let's just make a couple of observations and then we'll follow our order of operations to figure out why this measure isn't working. In our first item in the order of operations, we detect the coordinates of the measure location on the visual. Next, we're going to apply the coordinates filters to each respective table. So we'll see that we have a percent of total sales measure here, and we're also filtering this by audio, and then we're also filtering it by Bluetooth headphones. But as we know, the calculate function can hop in there and actually get it to negate some of these filters, which is good. Because if these filters stay, then of course, over 42 million change is going to be 100%. So we need to make sure that both of our filtering criteria are actually taking place where we want them to take place and not taking place where we don't want them to take place. For instance, our percent of total sales measure takes into account the total sales all product categories measure that we designed. If we go and look at our total sales all product categories measure, that clears all the filters from the product category table. Okay, let's go look at our data model really quick. If we negate filters on the category table and then reapply filters on the subcategory table, then the most downstream filters, which are the filters on the subcategory table, are going to persist all the way down to the fact sales table. Meaning, in our visual here, our number, our measure, is clearing out all the product categories, but then after that, it actually continues to filter for just Bluetooth headphones. So of course, the result by our percent of total sales measure, which is using our total sales all product categories, the result of our total sales all product categories measure here is happening before we actually reapply the product subcategory. Meaning, the calculate function is applying too high of a table. Meaning, we need to redesign a measure that actually intentionally negates the filters that are on the product subcategory table. In this case, it's not enough to just negate all the filters on the product category table, because right here we can see that an additional filter is being applied to the product subcategory table. Okay, let's go ahead and see this in action. We're going to need to grab our total sales product categories measure and just recreate one that is total sales all product subcategories measure. So you can copy and paste it if you'd like, but we are going to have to make a couple of changes. So I'm going to walk through it item by item. You can follow me if you'd like, or you can copy and paste it and try it on your own. I'm going to click on New Measure, and we're going to call this Total Sales All Product Subcategories. And this is going to use our calculate function, of course, and take into account our total sales, except it's going to clear all the filters that are on the product subcategory table. Okay, this should fix our problem. And now all we need to do is modify our percent of total sales measure to create one that says percent of all parent category sales. Because if you think about it, this particular measure is only clearing all the product subcategories. And all that means is that any existing product category will stay, but our product subcategories will disappear. Meaning it will tell us what the percentage is of the parent category, in this case of audio. All right, so we have one more measure to create in order to actually get the percentage. One more measure. And we'll call this percent total sales of parent category. This is going to take our total sales and divide it over that measure that we just made, which was total sales all product subcategories. Let's try that one instead and see if it looks better. Okay, looks a little bit better. Now, of course, you will want to modify this so that it's actually a percentage. And then it should look perfect. I'm going to remove the percent of total sales off of my visual, and that will continue to update those numbers a little bit there. For this next example, let's go ahead and start ourselves a brand new page. On this page, we want to do an analysis that is able to determine the total sales for things that are low promo and determine the total sales for things that are high promo. So anything that we consider high promo, we want to be able to see all the sales for that. And we've decided ahead of time that anything that's high promo might be greater than a 10% promotion. So we're going to need to start by creating a measure that actually figures out what the average promotion discount might be of a selection of our data. So we're going to go ahead and do that really quick. On the promotion table, you'll see that there is a field called discount percent. And if we switch over into data mode, we might get a better view of it. So we do have a lot of discount percents. A lot of them do happen to be above 10, but some of them are below 10. And we have decided that anything above 10 is generally considered a high promo, and anything below 10 is considered a low promo. What we want to be able to do is take a large selection of our data that maybe isn't listed out by promotion at all. Maybe we're looking at a bunch of other information about our product categories. We want to be able to see for everything that we sell in audio, how much of those sales are greater than 10% and how much of those sales are less than 10% promotion. So we're going to need to create a measure that actually looks at all the discount percents of any selection of our data and is able to create an average. Once we've actually created an average, then we can use that average to actually compare it to the 10%, or to see if it's greater than that or it's less than that. So let's start by creating those couple of measures. I'm going to right-click on the promotion table and create a new measure. We're going to call this measure average promo. And this is going to be a simple measure. It's just going to be an average of our promotion table's discount percent, which should be right there. Now let's go back and build ourselves a little visual so we can actually see this in action. Let's say we want to be able to look at all of our product categories. I'm going to grab my product category name field and drop it on the canvas. And just to start off with, let's just grab our basic total sales measure, so we have something to start off with. And I'm going to convert this into a clustered column chart. Now that I have the total sales, I do want to be able to see what portion of the total sales are low promo and what portion of the total sales are high promo. So I'm going to go ahead and create a new measure here. I'm going to place this measure on the fact sales table. We did create the last measure on the promotion table. That's because it specifically had to do with promotion data. It actually doesn't really matter where you put your measures. So I recommend that for the most part, you keep all your measures in the same place to keep it simple for you. So I'm going to right-click on the fact sales table and we're going to create a new measure here. All right, so we're going to call this total sales low promo. And as you might suspect, I'm going to use the calculate our total sales. But this time I'm going to use a filter criteria that says I only want to calculate this if the average promo is less than 0.1. Okay, I'll close out my parens like normal. I'll go to execute it, but I'm going to have a problem. I'll get a little message that pops up that says a function calculate has been used in a true or false expression that is used as a table filter expression. This is not allowed. I'll tell you exactly what's happening here that's causing the problem. We are comparing a measure in a true or false evaluation. That greater sign just tests to see whether a particular number is greater than or less than that number, and the only answer to that could be true or false, yes or no. So anytime you use your greater than or less than symbols, you're essentially performing a true or false operation. Now, a true or false expression can be used with measures, not in regular calculate. In order to fix this, you're going to need to use your filter function. Your filter function is a rescue function for calculate. In this case, all I'm going to do is put in filter Now, the filter function does need to know which table it's going to be filtering here. So I'm just going to say, okay, we are going to filter everything on the promotion table if the average promo is less than 10%. All right. Now I've opened 2 parens, but I've only closed 1 paren. So I'm going to need to close that second one. And when you execute that, that should work fine. Let's go ahead and see if it worked. We're looking for total sales, low promo. I'm going to drag it and drop it on my visual. Okay, looks pretty good. If you haven't done so already, now's a good time to pause the video and go ahead and create this calculate function. The challenge that we ran into is that we had a measure that was looking at the discount percentages in our promotion table. But we were asking that measure to be compared as less than or greater than a regular number. And your regular calculate function can't really handle that. And so we're going to need to use a filter function, which is a helper function that's specifically going to filter out your promotion table based on that logical test. When you're done, go ahead and try to create your total sales high promo. It's going to be basically exactly like this, except we're just going to ask if the average promo is greater than or equal to 10%. Go ahead and give it a shot now. If you have added your total sales high promo to the same visual, it should look roughly like mine. Now in this case, I probably would want to do a stacked column chart for this and then get rid of the total sales measure. So I'm going to get rid of total sales all by itself, and then I'm going to stack low promo and high promo. I'll probably want to make sure low promo is on the bottom, and then I could put data labels on here to specify each one of these. That at least gives my decision makers an indicator of how much this totals out to. If you really do want them to be able to see total sales, you're not going to want to put it on the visual, but you could easily put total sales in the tooltips. And that way, when you hover over one of these items, you will still see the total sales for everything. And then you'll also see high promo. And then if you hover over low promo, you'll see that as well. Well done. Make sure that both of your measures work that we just created, high promo and low promo, and then come on back and we'll continue. For this next example, I'm going to have us once again start from a completely blank page. For this next analysis, we're going to want to look at our total sales information. And we want to analyze all of our different product categories. But I do want to see this on a table. And the reason that I want to see this on a table is because we're not just going to look at our total sales information. We're going to look at our total sales as it could be expressed in euros. And then for a challenge, you can also try and do this in the Chinese yen. I'm going to change my text so that it's a little bit bigger here. So I'm going to go to my format options for my table, go to general, and I'll change that text to 14. Right now, we're seeing the total sales for each product category, and that's great. But if we wanted to create another measure that was able to take our total sales and divide it over some kind of a conversion rate, then we could also end up seeing the results of these total sales expressed instead in euro form. So our first example is going to be to see this expressed in euro form. Now, the only problem is that the conversion rate from dollar to euro does change on a regular basis. If I hard-coded some kind of conversion rate from dollar to euro, then I'm going to have to be going way back into my measure. First of all, remembering which measure it was, remembering all the measures that are connected to it, being really careful to change it and anything that's dependent upon it every single time the conversion rate changes. And that's way too much work. So what we're going to do is we're going to put a slicer on here that populates all different available conversion rates to choose from. Now, what we're going to need to do in order to get a slicer like that is to actually get that kind of data into our data model. So let's start there first. We do not have any data in here that populates conversion rates, so we're going to need to make one. On the Home tab of the ribbon in Power BI, you'll want to click on the command called Enter Data. This is going to allow us to basically design a table from scratch. I'm going to go ahead and enter in some different values in here. And we could name this table USD per euro. And we might have conversion rates like 1 and 1.1 and 1.2, 1.3, 1.4. All right, we'll stop there. You get the idea. And we're going to name this table USD per euro. Okay, and load it. Now that we've created this table called USD per euro, we can now take the USD per euro information and put it on our canvas and turn it into a slicer. Now we have all of our different USD per euro conversion rates. The only problem we're going to have here is actually getting the numbers that are chosen on these slicers to be pulled into some kind of a measure. Now, we can do this, but the way that we do this is using what's called a harvest measure. In order to create a harvest measure, you'll want to create a measure like normal, but we're going to need to create the measure on the USD per euro table. I'm going to right-click on the USD per euro table and create a new measure. And we'll call this euro conversion. Now, when you are creating a measure, there's no way to just simply select a value in a table. You have to harvest the value that's in that table. As you probably already know, all the data that's contained within Power BI or within Power Pivot, it's not modifiable as individual values. It's only modifiable or selectable or usable using measures or columns. In this case, what we're going to do is use a measure to select the item that's been chosen here. Now, if you think about it, the item that's been chosen, this has been chosen on a slicer. And slicers are filters, which means that we have now filtered out the USD per euro table for only the 1.00 value. What that means is that all that's left on that table is 1.00. So all we have to do is fetch whatever single piece of information is left on the USD per euro table. We are going to need a function to do that, though. Unfortunately, we can't just say euro conversion equals USD per euro. You'll notice that we're not able to just type in the table name here. We're going to need to use a function around the outside. And this is a pattern that you will see throughout Power BI and throughout Power Pivot in Excel. You cannot have any naked measures. Naked measures are referred to as measures with no function in them whatsoever. So measures must always have a function. In this case, it doesn't really matter which of the common aggregation functions we use. We could use average, that would be fine. Because if you think about it, there's only going to be one value left on that table, and so it's averaging up one number. Fine. We could also use max. Because once again, if you think about it, we're only going to be maxing one number. Doesn't matter. We could use sum. It doesn't really matter which one you use. I'm going to use max. And then all I'm going to do is say I want the USD per euro table and then the USD per euro column. And if you want to check and see if this is working, what you can do is you can grab your euro conversion measure that we just made and either put it in a card visual or put it in your table. That would be fine too. And then you should notice that when you select different things on your slicer, whatever's in that card should also modify at the same time. So now you can see that that harvest measure that we created is actually working. Great. So now that the harvest measure is working, all we need to do is pop this harvest measure into a measure that actually takes total sales and divides it over the conversion rate. All right, that's going to be easy. I'm going to go to the fact sales table and create a new measure there. This measure we can call total sales euro. And all you should need is the total sales your regular total sales measure, that's actually our euro conversion measure. Euro conversion. There it is. Okay, let's look for total sales euro. All right, in our total sales euro measure, I'm going to pop it into our table here, and now we should see total sales and total sales euro, and as I choose the different USD conversion rates, I should see that the total sales euro is being modified to reflect the chosen conversion rate. All right, now it's time for practice. So we've learned how to do this once. What we're going to do is we are going to do this one more time, and you're going to try and do it on your own. When you come back, I'm going to have an example displayed here so that you can see what yours will look like if it's correct. We're going to create another one of these conversion tables, except instead of euro, we're going to do the Chinese yen, which is also referred to as the renminbi. Not sure I'm pronouncing that correctly. The different conversion rates might be something like 0.1, 0.15, 0.2, 0.25, and 0.3. What you want to do is, first of all, take this data and enter it as new data. This is going to create a separate table here. Now, keep in mind, this table never actually got related to the rest of our data, and we want it that way. We're intentionally using this disconnected table to be able to use it as a slicer that allows our end user to choose one of the inputs. And then we harvest that choice by our end user. We harvest that with a harvest measure. And remember, you're going to need to create a harvest measure. And that might look something like renminbi conversion, which will equal max, and then whatever your table name is, and then whatever your column name is. Once you do that, you will need to create a measure that actually takes the total sales and converts it into renminbi. That might look like total sales renminbi, and that would be your regular total sales measure divided by renminbi conversion. Now, the one thing we did not do in the last example was actually change our total sales euro so it's no longer dollar signs. Okay, we have dollar signs there. That's not ideal. So you're going to want to change that one for total sales euro, and then also see if you can change the measure that you create here in this lab. Change this to Chinese yen or renminbi. All right, and with that, go ahead and give it a shot. The lab results for the previous exercise should look something like this. First of all, we did need to convert the formatting here to euro, and then when you created your Chinese yen or renminbi calculation over here, then you'll want to make sure to actually use that yen character. Additionally, you should have a USD per yen or renminbi slicer over here that allows you to select the different options. On this one, I selected 0.15, and that is returning the result of 21,708,000,000 and some odd change in there. If you haven't done so already, you'll want to make your USD per renminbi table. We did that by using the Enter Data feature. That's on the Home tab in Power BI. And we created a table by hand and entered in some conversion rates there. We did also create a measure that harvested that data. So if you haven't done so already, you'll want to do all of the above and then come on back and we'll continue. Welcome back. For this example, I'm opening up a page that we worked on previously in this course that has a lot of visuals on it. The reason I'm doing that is because we are going to make a quick observation about how the visuals interact with each other on a single page. And then we're also going to talk about how to modify those interactions. So I'm going to start by taking a look at this pie chart that I have on the left-hand side. Each piece of the pie corresponds to a particular product category. If I click on one of the pieces of pie, that selection of that piece of pie serves as a filter for all the other visuals on my page. It's as though I'm actually clicking on the slicer item called audio. If I click on that slice of the pie again, I will turn off that filter and everything will return to normal. If I wanted to instead use a slicer, I might want to slice by Asia, which turns out I'm already sliced by, or I could turn that off by simply clicking on the slice that I already have on Asia. So that's the basics of using the built-in filters that are part of each one of the visuals in Power BI. Now, just by the nature of each one of these visuals and the interactions, each visual is actually interacting with all the other visuals on the page. But sometimes you want to be able to turn this off. For instance, sometimes I want to be able to choose one of my product categories like audio, and I do want to be able to slice my map visual by audio, and I want to be able to slice my clustered column chart visual by audio as well. But my pie chart is going to look rather silly over here. Since all that's left is audio, that's the entire pie chart. So maybe I want to be able to modify the interaction between the product category name slicer and the pie chart so that the product category name slicer actually has no effect on the pie chart and it stays like the normal pie chart. To edit the interaction between any 2 or 3 or 4 visuals, however many you want, you're going to go to the Format tab of the ribbon in Power BI. All the way on the left-hand side, you'll find a command called Edit Interactions. By clicking on that command, you now have the ability to select a given visual, like this slicer here. If I select this slicer here, I now have the option to choose how this interacts with any other visual on my page. For instance, I want to turn off the interaction between product category name and this pie chart over here. So what I'm going to do is find the little icon that just showed up above the pie chart. Now currently it's being set to filter this visual, but I want to turn off that interaction, and so I'm going to click on None. Now, when I use this slicer over here, I can slice by audio and it affects all the other visuals on my page except for the one that I turned off. So thankfully, it's not actually slicing this pie chart and making it look a little silly. Let's say I want to be able to do this for another visual. I want to be able to use this continent name slicer here, and I want to be able to choose a continent. But when I choose one of these continents, I only want to slice the pie chart and my time scale over here. I don't want to actually slice the map because I still want to see a nice topical view of all the different regions that we sell in. So what I can do is select this slicer now, and then I can see its interactions with all the other items, including its interaction with the map. I'll go ahead and turn that back to none, and you'll see that it turns off the effect that this slicer had on the map. If you haven't done so already, now's a great time to pause the video and try this out for yourself. Remember, you're going to need to go to the Format tab of the ribbon in Power BI and click on the button on the left-hand side that says Edit Interactions. If you don't actually see the Format tab, it's because you haven't clicked on a visual. So just start by clicking on one of your visuals, any visual will do, and then click on the Format tab. Sometimes you're going to need to take a report that you've designed and distribute it to a lot of people. On occasion, you're going to need to be able to decide exactly who can see what type of data. And so it's worth it to talk about row-level security. Now, before I actually get into it, I'm just going to mention that this is a Power BI Pro feature. And so in order to get access to this and be able to utilize it online, you are going to want to get Power BI Pro. But assuming that you have Power BI Pro, you can easily go to the Modeling tab of the ribbon in Power BI. And on the right-ish hand side, you'll see a command group called Security. So row-level security means that you're going to be controlling exactly which rows of original data anybody can see the results of, depending on what kind of roles they have. So if somebody has a role that has to do with sales, you might want to show them all the sales information across the entire company. You might not want to show them payroll information for the entire company. Likewise, somebody who's in HR probably needs to see all the payroll information, but probably isn't going to need to see or analyze any of the sales information. So what you can do is you can design specific roles that allow people to see certain things. And the way that you're going to do that is you're going to click on Manage Roles. I'm going to create an example. Let's say I'm going to be sending this out and I want people in the United States to be able to see the United States data. And then I want people in a particular country in Europe to be able to see European data. And then I want people in a particular country in Asia to be able to see the Asia data. What I'm going to do is click on Create. And then I can create a role, like we'll say US, or better yet, we'll say this is the role for anybody in North America. And what I can do is click on any one of these tables, like we'll say geography. I'll right-click on geography and say I want to add a filter. And I'm going to add a filter for continent information. Now, this is my continent number. If you were here at the very beginning of class, you'll know that that's just a continent number. But down here, I do have continent name. I'll go ahead and click on continent name, and then I can actually specify a continent name here. So one of our continents is named North America. And then I've designed a role for my North American users that can see all the information, but only from the continent called North America. I'll go ahead and click Save here. And in a normal scenario, I would probably create the roles now for everybody at the same time. Right now, I'm still seeing it from a programmer's perspective, meaning I'm not looking at any of the roles, I'm looking at all the data. But if I do want to see what it's going to look like if you were a North America user, I would go to View as Roles, and then I would say I want to see it as a North America user, and I'll click OK. I'll give my report just a minute to be able to slice all the information and change the display, and there we go. So it looks like we're still seeing some European information, and this is kind of interesting. I know that what is happening here is that Power BI is actually incorrectly understanding one of the city names that we have here. So because we're using some of the city information, we're actually still getting some data, and it's popping up on our visual here. There are lots of really great ways of working around this, and it all depends on your data. But you'll see on my slicer, I only have the option to see North America data. This is actually a really good time to take a look at your data and make sure you're not having any weird glitchy things happening like this. This is a great way to troubleshoot. Why don't you go ahead and give it a shot? If you haven't done so already, go to the Modeling tab in Power BI and create a role for somebody at your company. And then you'll go ahead and create a filter there. And then you'll want to make sure to try it out by clicking View as Roles. And then come on back. Our pages and our report are looking pretty good so far, but there comes a time in which you might want to be able to display some data on some visuals that don't actually exist already. So you'll see that we have these built-in visualizations over here on the right-hand side, and we have explored a lot of them, but maybe none of these visualizations actually work for the type of data that you have. It's really important to know that there is an entire gallery online of a bunch of really neat custom visuals that other people have built. We're going to go there together. We're going to fetch a couple of the custom visuals, and we're going to show that on the video here. And then after we've done that, what you're going to do is you're going to pause the video, and you're going to download every single one that you think looks cool and try and figure it out. I'm going to go ahead and open up my browser. And I'm going to go to https://app.powerbi.com/visuals. It's important to know that there is an entire community online of people that are excited about Power BI and learning about Power BI just like you. Right here, we're at the app.powerbi.com/visuals, but I would encourage you to also just go to Google and type in Power BI community. There's an entire community here, and we're all really supportive of each other. Particularly here in the visuals area, we can see a bunch of visuals that other people have submitted to Microsoft, and Microsoft has said, hey, that's pretty cool. I'll bet a lot of other people would like to use that too. If you scroll down in the visuals, you'll see lots of different types of visuals that you can use. When you see one that you like, all you have to do is click on it. I'm going to click on the one called Enlighten Aquarium. When I choose Enlighten Aquarium, I'll see the option to either download the visual or download a sample. Now, it turns out that this is a really simple visual, so it's actually going to be really easy to use. However, if I download a more complex visual and no amount of me playing around with it is helping me figure out what to do with it, then I highly encourage that you download the sample. The sample is optional, but what you're really going to need in order to actually get the visual and use the visual is the button that says Download Visual. So I'm going to go ahead and click on Download Visual, and you will get a message from Microsoft, and you will want to read the whole thing. I've read the whole thing before, so I'm going to go ahead and click on Agree. You'll see that my aquarium is now downloading, and I'm using Google Chrome, so that's why you'll see it download there in the bottom. Okay, now that I have it downloaded, all I have to do is return to Power BI, and then I actually need to pull it into Power BI. This little dot, dot, dot in the lower right-hand side of the visualizations pane, this allows you to choose from a couple more options, including import a custom visual. I'm going to go ahead and import a custom visual. And you'll get another notice. You will want to read that entire thing as well. I've already read it before, so I'm going to click on import. Your custom visual is going to be in your downloads folder. So I'm going to go ahead and click on my downloads folder, and then I'm going to choose this aquarium that I downloaded today. And I'll click on open. I'll get a message saying that that was successful. Go ahead and click OK. And then over here in your visualizations pane, in just a second, we will see our aquarium icon pop up. There we go. There's my little fish. Okay, let's say I want to take this pie chart here and I want to convert it to my aquarium visual. I will just click on that visual and then convert it to an aquarium. That was pretty easy, right? This particular aquarium visual is actually really easy to use. All you have to do is put in some categorical piece of information under the fish well. And then the fish size well is going to require some calculable information. The fish size is going to be determined by the total sales of each product category. Now, I'm having a little bit of trouble determining which fish is which. Unfortunately, with this visual, there's not any built-in feature that allows you to put a label on the fish or under the fish or to the side of the fish. But if you hover over the fish will stop moving, and then you'll get your tooltip that pops up and says, this is the computer's fish, and this is the total sales amount of that. All right, now's a great time to pause the video and go online and find a visual that interests you. You'll want to do this a few different times with a few different visuals. Keep in mind, depending on the complexity of the visual, you might very well need to actually download the example and see what kind of data is used for that. For example, if I wanted to use this tachometer here, the designer of this has created a few different wells, and I don't actually know what those wells do. So I'm going to download a sample, and then I'll actually be able to see what their data looks like, what kind of data their data is. And that's going to help me determine what kind of data of mine I can use to be able to utilize this same visual. All right, go ahead and give it a shot. I recommend trying out at least 3 different types of visuals here. Pick the ones that jump out to you, and I recommend trying to choose at least one custom slicer because you only get the one option in Power BI. All right, go ahead and give it a shot and then come on back. Let's take a second to republish our data model. We published our data model at the end of day 2, at the end of our Power BI Essentials course, but let's go ahead and republish it with all the new information. Keep in mind that if you want to update any changes that you've made in your file, then you will need to republish it every time unless you set up something like a gateway. Let's go ahead and do that now. Now remember, it might take a little bit of time. When you're done, you'll get that same notice letting you know that you are successful at publishing to Power BI. You'll get a couple of different links here. The top link says Open Data Model in Power BI, and that will allow you to actually jump right into your browser and open up Power BI Online. Great. This is my report that is now online. And if I click on the hamburger on the left-hand side, I'll be able to open up and see my various dashboards that I've created. You might have only created 1 or 2 so far, all of the reports that you've pulled online, and all the data sets associated with all of your reports and dashboards. Let's take a moment to recall exactly how we might actually create a dashboard from this data in this report. I'm going to start by hovering over one of my visuals, and I'm going to find the tack icon that shows up there. I'm going to go ahead and click on that, and that's going to allow me to pin it to a particular dashboard. Now, I know that we've already created a dashboard, but you have made a lot of modifications in this file. So we might want to just create a new dashboard. And you can name it whatever you'd like. And then we'll go ahead and click on Pin. You'll want to take a second and pin at least a few different things onto this dashboard that you've just created. Now's a good time to pause the video and come on back after you've done that. Now that you've pinned some items to this great looking dashboard, we'll actually want to go to the dashboard that you've just created and go ahead and click on it. If you're asked if you want to save any changes in your report, just go ahead and click on Save. As we've already discussed in one of the previous videos, you will want to rearrange the items on your dashboard so that it's going to make the most sense to your viewers. So take a second to just move around the different items on your dashboard so that it looks really good to you. It's important to know that even though most of these visuals we designed in Power BI, you can actually take content that's in Excel and publish it to Power BI. It's not built with the exact same dynamicism and republishability, but it is important to know that you can do it. In Power BI on the upper right-hand side, you'll see this download icon. By clicking on that download icon, you'll be able to download some add-ins that are going to be very helpful for you. First of all, you can download Power BI Desktop. Now, if you've been following along with the class, you probably already have that. However, one thing that we haven't really talked about is a data gateway. This is particularly useful if you need to have data regularly fetched from your computer, or better yet, from some kind of centralized data hub and get it pushed up to Power BI Online. In that case, you're not going to want to click on the Publish button every time there's new data. So what you can do is you can design a data gateway, which is going to allow that data to be pushed into Power BI Online without you needing to do it manually. You can also download Power BI for mobile and a Power BI publisher for Excel. You also have a feature called Analyze in Excel, and you can get updates for that. What we want is Power BI publisher for Excel. If we click on that, you'll be taken to a place where you can actually download this add-in. Now, let's talk about what it actually looks like in Excel. In Excel, it'll show up as an extra tab of the ribbon. And you'll see some options in here to pin items from Excel into Power BI Online. You can even manage the things that you've chosen to pin, and then you can open Power BI. You can connect to the data, manage things about your profile, and then update. What I'm going to do is choose this great pivot table I've designed in Excel, and I'm going to go ahead and pin it. If you've already logged in to Excel, then you won't need to re-log in. But if you haven't logged into Excel, then it will ask you for your credentials. I've already logged in, so I don't need to retype my credentials. I'm just going to choose to publish it to my workspace, and I'm going to pin it to an existing dashboard, and it's the dashboard that we just created. So I'm going to go ahead and click OK. When I return to my Power BI dashboard, if I just scroll to the bottom of all the items that I've pinned to this dashboard, you'll see that I do have this pivot table preview that has been pinned to my dashboard. Now keep in mind, it doesn't work like a normal pivot table, but it is a nice little display of the results from that pivot table. Now, when I'm making pivot tables, I do a lot of KPIs, and I create conditional formatting, and I make those pivot tables really informative. And so this has turned out to be an extremely utilitarian tool for me in dispensing information from pivot tables. If you haven't done so already, now's a great time to go ahead and try out that download, and you can try out any of the other downloads here as well. Go ahead and give it a shot and come on back. This is looking pretty good on my computer, but what about if I wanted to look at it on my phone? On the upper right-hand side of Power BI Online, you can click on the ... and that will give you more options. If I click there, you'll see at the bottom it allows me to edit my view. Currently, we're looking at it as though we were looking at it on the web on a computer, but I can switch that to the phone view. Now, what's really neat about this is by clicking on Phone View, I can actually customize the design for what it's going to look like on my phone. I'll go ahead and click Continue here. And now you'll see it's looking pretty basic. What I had laid out on the web view was looking a lot better than it does on the mobile view. So I'm just going to go ahead and move around a couple of these items. I'm going to move my card visuals, and I'm going to move around a couple more items so that it looks more obvious and presentable on a mobile phone. Once I've redesigned that for my phone, now I can go ahead and look at it on my phone and see what it's going to look like. From my mobile device, I can click on my Power BI app. If you don't already have a Power BI app, just simply go to your App Store and choose the Power BI application, and you'll get it for your mobile device. I'm going to go ahead and click on Power BI there in the lower left-hand corner. And once I open that up, I'll be able to see all of the dashboards that I've created. I'm going to go ahead and click on the item called Great Dashboard. That's the dashboard that we just created. And by tapping on it, I'll be able to see this great mobile design I designed in the last example. It might take just a second for my mobile application to download all this information, just like it would as if I were accessing this information from a normal computer. I can scroll down in my mobile view to see different visuals and different metrics of my analysis. If I want to see more information about one of my items, like I want to see this line chart right here in the middle, I can simply tap on that line chart and then I'll be able to see more information. Turning my mobile device to the side is also going to show me a different view of the data than it would be by just holding it normally up and down. I also have the ability to annotate these visuals. In the lower right-hand corner, you'll see the item that looks like a pencil. If I click on the pencil, I'll be able to tap anywhere on the screen just like it says right there. I can go ahead and choose my ink color, and then I can circle something and say, great. It's going to look just about as good as the rest of my annotations that I do on my mobile device, which is not so good. So if I want to erase that, I do have that eraser icon in the lower right-ish hand side. And if I click on that, I can just go ahead and erase some items, including clear all annotations. I'll go ahead and click on clear all annotations, and that'll take that off. But if I've created some annotations or put a smiley face on here or something, what I can do is actually share this with one of my coworkers, and I'll be able to go ahead and share this through either a text message or email or whatever I'd like. Finally, whether we're on the mobile application or whether we're looking at it on the web, we might want to be able to get some kind of an alert if any of our data crosses a particular threshold. Let's say, for instance, our total profit margin is currently 56.48%, but I want to set up an alert that lets me know if it goes over a particular threshold. Maybe our goal for next year is to get to 60 or something like that. Now, I'm not going to be able to change my data enough to actually get that profit margin, so we're going to use an example. Like we'll say our previous goal was to actually get above 55% profit margin. Now you see that we've already done that, but we're just going to set up an alarm that already looks for 55% just so that you can see how easy it is to set up, and then you'll actually see it in action. On most of your visuals, you'll have the ability to click on the ... item at the top right. If you click on that, it basically flips your tile around, and you can see some more options that you have with this. You will see an option that looks like an alarm bell. And if you hover over it, it will say Manage Alerts. I'm going to go ahead and click on that. I currently have no alerts set, so I'm going to add an alert rule right here. I'll call that alert for total profit margin. That's totally fine. And the condition is that it is above, we'll say 55%. So I'll need to put in 0.55. Now you can set it up to have a maximum notification frequency, which in lots of cases you're going to want to be careful about that, because if you have a flexible alert margin that you're going over on a regular basis, you can get notified too often. So usually we want to know if it happens every day or so, but you can set it up that you can get it once an hour. Okay, I'll go ahead and click on Save and Close. And once that data actually crosses the threshold, I will get an alert, not only here in Power BI, but even if I don't have Power BI online open at the time, so long as I am logged into my online profile, I'll get a notification that pops up on my screen. Very well done. Congratulations on completing the Power BI Bootcamp. On behalf of myself, Chelsea Doman, and all of us here at Learn It, thank you so much for joining us. It's been a pleasure. We'll see you next time.